Hello and welcome IGCSE Physics Enthusiasts. Today, we are embarking on an incredible journey into the world of physics, where we will uncover the secrets of the universe and understand the fundamental laws and govern our physical reality. Physics is the branch of science that seeks to explain the behavior of everything around us, from the tiniest subatom particles to the vastness of space. It is the key to understand the how and why behind the natural phenomena we observe every day. Throughout this online study, we will delve into a wide range of topics from mechanics and electricity to wave and energy. This concept will not only help you excel in your IGCSE physics examinations, but also lay the foundations for future studies in science and engineering. Without further ado, let's get started. Let's look into the introduction. The physics is the foundation of natural sciences. And in order to understand the behavior of the universe and matter in it, to account the observations of the interactions between universe and matter, the scientist has invented the theories. Various experiments are conducted to test and validate those theories. As a conclusion, from the test and validation of those theories, and accurate results are obtained by accurate measurements on the observable physical quantities. Why do we need to understand the need for standard unit of measurement? During the first half of 19th century, there was inconsistency in the choice of preferred multiples of base unit, and different system of measurement is being used until end of Second World War. In 1954, they finally decided that an international system should be derived from 6 base units, base or standard quantities. Thus, the standard system of measure adopted in physics is called International System or Unit or System International, SI. SI system is divided into several categories. One is a base quantity. What is actually a base quantity? A base quantity is chosen by the scientists to represent a base unit which acts as a basic set of measurement and together with the 5 base quantities. Meanwhile, a derived quantity is a unit measurement that results from combination of base quantity, and similarly, its derived unit is the product and cohesion of this base unit. All quantities in every physics questions will have to be converted to SI units, means that System International, before any formula is used or any calculations is made. Let's look into the System International based on base quantity. You might have the length, the unit symbol used is M, and the unit name is meter. For the mass, the unit symbol to measure the quantity of mass is in kilogram. And time, the unit symbol used is S, which represents second. Electric current, the unit symbol is used A, which is represent ampere. Temperature is K, which is actually represent Kelvin. And amount of substance, we use the unit symbol is mole, or we call it as mole, M-O-L-E. Let's look into the derived quantity. Derived quantity, for the system international, the quantity like angle, we use RAD, or it represents radian. And in terms of derivation, is a dimensionless. Force, the unit symbol is N, which is represent Newton. So derivations is from mass, time, or distance. Meanwhile, frequency, we use the unit symbol Hz, and the unit names is Hertz, and is actually derivation from time. And we have energy, and the unit symbol is J, and we shall represent joule, and derivations is from mass, time, or distance. And voltage, unit symbol is V, unit name is volt, and derivation from current, mass, time, and distance. And finally, we have a quantity like magnetic flux. The unit symbol is VB, and it represents Weber, and derivations from current, mass, time, and distance. Then looks into the types of errors. Type of errors is divided into two types. One is uncertainty, and B is experimental error. What does it mean by uncertainties? That with regards to error, uncertainties means that all data is derived from observation or measurement of a value at one point on a measuring scale. All experiment data has to be associated with elements of uncertainties. Generally, a reading can be estimated to 0.5 of the smallest division on measuring scale. Meanwhile, experimental error is referring to random errors or systematic errors. Random errors is affected by the precision of the experimenter, which only have certain degree of accuracy, which is due to random errors. It could be due to imperfect tools when you use during the experiment, human reaction time, or environmental condition. Meanwhile, systematic errors, it affect the accuracy of experimental result, which make the value always smaller or larger than the true value. And it is systematic errors is could be due to instruments, it could be human judgment, we call it as parallel error, or is a wrong usage of the instrument. Let's look into the measuring technique. There are several tools used to measure length, and the most commonly used ones are ruler, vernier calipers, micrometer screw gauge. Ruler is the smallest unit of measurement, and it can carry the value up to 1 millimeters. How to use it? You have to line up the end of the ruler with the end of object you are measuring, and you have to make sure the ruler is steady, won't be moving around. If the measurement is right on the 6.2 mark, then it should be reported as 6.20 centimeter. However, if the reading line between 6.1 and 6.3, then it should be reported as 6.2 plus minus 0.05 centimeter due to uncertainty. Then we have an equipment is using vernier calipers. Okay, if you see this instrument, you have this internal jaw, we have external jaw, you have a locking screw, and this part is called imperial scale, and this is so-called metric scale. And we have this, if you see on the right hand side, they will be called depth measuring blade. And what is actually vernier calipers? Vernier calipers, it gives such a big, precise for measuring instrument, and the accuracy is 0.1 millimeter, as the smallest division on vernier scale is 0.1 millimeter. And in terms of the reading error, is half of the accuracy. The reading errors is estimated about 0.05 millimeters. And how to use the vernier calipers? The internal jaw, you can see in the diagram, are for measuring internal diameter, and the external jaw, this part, the bottom part, for the external diameter. So when you want to use this, you have to unlock the locking screw, slide external jaw and internal jaw together. You have to slide this together. When the jaw of vernier calipers are closed, the zero on the main scale should coincide with the zero on the vernier scale. Then, if no error, then you proceed. Then you have to unlock the locking screw, slide jaw to place the object to be measured between any of the jaw depending if internal, external diameter to be measured. And then finally you have to secure the object by fastening the locking screw. Okay, that's it, how to use the vernier caliper. Then you can measure what is actually the readings. On top of that, this is actually to show you the scale, what is actually exists at the vernier caliper. So it consists of two parts. One is a main scale, and at the bottom part, they call it a vernier scale. If you look at this, you can see that the cm reading is taken at the division that is right before the zero mark. And on the vernier scale, refer to the image below. Okay, if you see this, this is actually, if you look at the main scale, the reading is so-called 4.3 cm. So on the top part is actually referring to cm value. Meanwhile, at the bottom part is referring to mm value. But remember, so when you want to add up the value, you have to translate it into the same value number. So in this case, the main scale is in centimeter. You have to convert the vernier scale into centimeter as well. So the mm reading is taken at the division on the vernier scale that coincide with the main scale. Refer to the above. Okay, so at this point, you read as the main scale as 4.3 centimeter. Meanwhile, at the bottom part, vernier scale is referring to, it's come from this 0.5 mm. So when you want to add the reading, total up, adding the reading from the main scale and vernier scale, you have to obtain the final reading. So what you can do is, you have to convert 0.5 mm, where you get the reading from vernier scale result, into centimeter. Then you can get the whole final reading will be 4.3 cm plus 0.05 centimeter. It becomes the reading 4.35 centimeter. This is how you want to use and you want to read the vernier calipers. Okay, let's look on the part of positive error and negative error. If the first zero on the vernier caliper scale is to the right of the zero on the main scale, then this error is considered a positive zero error. You can see where is the zero. Okay, this is the zero of the main scale. So, if it says that the rules is, if the first zero on the vernier caliper scale is to the right, of the zero on the main scale, then this error is considered a positive zero error. So you see the error is at 0.03 centimeter. So the error must be positive. Therefore, the zero corrections should be reported as a positive sign. Meanwhile, if you look at the negative zero error, the clue is if the first zero on the vernier caliper scale is to the left, means that is to the left, the zero starting is here. So on the main scale, then this error is considered a negative zero error. Therefore, the zero correction should be reported as a negative sign. If you see the error here is 0.04 centimeter, then the sign should be negative. Because why? Because the vernier caliper scale is to the left of the zero on the main scale. Okay, let's look this example where you have to get the corrected reading where you need to add up or minus, you have to minus the zero error in order to get the correcting reading. For the positive zero error, the clue is if the first zero on the vernier caliper scale is to the right, okay, is moving to the right of the zero of the main scale, then this error is considered a positive error, zero error. Therefore, the zero correction should be reported as a positive. Refer back to this reading previously. Is this error indicate the reading is 0.03? In summary, it shows that how you need to incorporate zero error corrections into your actual reading or into your final corrected reading. So you have, assuming that your actual reading is 5.14 cm, you have to minus plus 0.03 centimeter. So the actual reading is 5.11 centimeter. Means that 4.11 centimeter is the actual reading. The reading after you minus the positive zero error. On the other hand, how to get the final readings for the negative zero error? Assuming that your negative zero error is negative 0.04 and assuming that your actual reading is 5.14 centimeter, you have to minus negative 0.04 centimeter, you get the value of 5.18 centimeter. This is how you want to use vernier caliper when there is existing of positive and negative zero error. Let's look into the next equipment, which is using micrometer screw gauge. What is the function of micrometer screw gauge? Part of the micrometer screw gauge is a U-shape. You can see from this diagram. And the purpose is to measure specifically external diameter. And you can see there is existing of this part which is called anvil and spindle. And actually these two items, anvil and spindle, is act like external jaw of the vernier caliper. So from this, how to read the items here, the element that exists in this instrument, you have the anvil and spindle, you have the sleeve with the vernier graduation, and this is the lock, and this is the frame. This part, they call it as timber, and this is a ratchet stop. Okay, how to use this micrometer screw gauge? First, you have to loosen the ratchets until the anvil and spindle comes together and check for zero error. And never turn the timber scale to bring together the anvil and spindle which is it may damage the micrometer, and introduce the zero error. And then we have to use the ratchet. Where is the ratchet? This part on the right hand side, to unloose the anvil and splinter, then secure the object such as its geometrical center is perpendicular to the anvil and splinter, to be measured by adjusting the ratchets. And do not over tighten the ratchets when securing the object to be measured. Okay, you can see this is the measurement on the micrometer screw gauge. If you can remember, what is this? We call it, this is the timber. Okay, what is actually indicated here? So the first reading is contributed by the mean scale, which is millimeter, and has an accuracy of 0.5 millimeter. And the second reading is contributed by the two rotating vernier scale on the timber and has the accuracy of 0.01 millimeter. And the micrometer reading is 2.5 millimeter on the main scale and 0.38 millimeter on the timber scale. And the final reading will be 2.5 millimeter and plus 0.38 millimeter, you get the value of 2.88 millimeter. Let's look into the positive zero error. The positive zero error is when the zero marking on the timber scale is below the datum. Okay, you can see here. So the reading on the timber is 0.123, means that 0.03 millimeter. And by assuming that you get the value here, the final reading is 2.88 millimeter. You have to minus plus 0.33 millimeter to get the value of 2.85 millimeter. And meanwhile, for the negative zero error, where you have the reading in the timber here, which is represent negative 0.03 millimeter. And when you want to get the calculations for the final reading would be 2.88 millimeter minus negative 0.03 millimeter, then you get the value of 2.91 millimeter. Okay, let's look how we use the graduated cylinder and pendulum. What is a graduated cylinder? The use is to measure volume and density, which is volume of a liquid with a high degree of accuracy. Useful to measure liquid in millimeters, small m and capital L, or cubic centimeters, etc. How to use it? When you select appropriate cylinder, clean and dry, then pour the liquids. Then you have to observe the meniscus. Meniscus means that meaning the liquid in cylinder will form a curved surface called meniscus at the point where it appears to touch the graduated scale. And finally, you have to really ensure your eyes is at the same level as the meniscus for an accurate reading. Let's look into pendulum. Pendulum is a very simple mechanical system consisting of weight, often called a bob, suspended from a fixed point, which is allowing it to swing back and forth. Classic example of harmonic motion in physics. It is used for timekeeping, and pendulum clock we use for accurate timekeeping. The regular swing of the pendulum acted as metronome to regulate the clock's movement. Pendulums can be used to measure factors like gravity or the acceleration due to gravity. By measuring the periods of oscillations, can determine the value. That's all for today that I have for you. Hope that you really understand this subject matter. If you have any problem or any question, do provide me the comment about these presentations today. And if you would like to have this presentation slide, please email me at the below addresses. And finally, please don't forget to subscribe to Germ Study Lab YouTube channel. That's all for today. Hope to see you in the next chapter. Thank you very much.